This lecture is on the geology of California. There's no chapter in your textbook that covers this material, so I made a screencast of my lecture slides from last semester. There's no quiz on this lecture, but material from this lecture will be included in exam number 2. So let's start with the fact that California is divided into 11 geomorphic provinces. The term geomorphic refers to the shape of the landscape, so these provinces are classified by their unique landscapes, which are mostly determined by the geology and the climate. I'm going to go through these 11 geomorphic provinces one at a time with an overview of their characteristics. The first geomorphic province I want to talk about are the Klamath Mountains. They are considered a northern extension of the Sierra Nevada, and peaks will reach up to 8,000 feet. They also contain gold-bearing gravels. The Cascade Range is a chain of volcanic cones extending from Washington down south through Northern California. These are stratovolcanoes, which are the results of subduction zones, and the subduction zone off the coast of Northern California up through Washington and British Columbia. In California, Mount Shasta is one of the most southern extent of this Cascade Range, and it's 14,162 feet in elevation. In addition, a tributary of the Sacramento River flows through this region. The Modoc Plateau is located in northeastern California, and it's considered a volcanic tableland built of lava flows and ash or tuff beds. The magma that is part of this volcanic area is primarily basalt. So in general, there are no explosive eruptions like stratovolcanoes have. The Modoc Plateau is cut by many faults, which trend north-south and is bounded by the Cascade Range on the west and the Basin and Range to the east. So the Sierra Nevada is what is called a tilted fault block, which is 400 miles long, and its highest point is Mount Whitney at 14,495 feet. It contains the golden veins within the rock, and this is where the term mother lode comes from. Its northern boundary will disappear under the Cascade Range. The Coast Ranges are mountains that may be familiar to many of you because they are the mountains that are often to the west of populated areas of the Bay Area. The northern range is separated from the southern range by San Francisco. They're also to the east of populated areas in the Bay Area. So the Santa Cruz Mountains are part of the Coast Ranges. These ranges tend to run nearly parallel to the trend of the San Andreas Fault along the coast of California. The Great Valley is a large alluvial plain 50 miles wide and 400 miles long, consisting of both the Sacramento and San Joaquin valleys. An alluvial plain is a generally flat region composed of sedimentary deposits. The Great Valley has a pretty thick layer of sedimentary deposits, and this is one reason why the soil is so fertile and there's much agriculture there now. In addition, the San Joaquin Valley has oil fields because oil can get trapped in sedimentary rocks. Also, there's a small isolated volcanic formation called Sutter Buttes near the city of Sacramento, and it is considered by some geologists to be the southernmost extension of the Cascade Ranges. The Basin and Range is located in the eastern part of California. It consists of normal faults, which are vertical faults where one block drops down relative to another. This type of faulting creates a landscape of mountain ranges and adjacent valleys, which is why it's called the Basin and Range. It includes many lakes and dry lake beds, which are also called playas, including Death Valley and Owens Valley. Because the climate in much of the basin tends to be dry, and many of the streams and rivers are what are called internally draining, which means they don't drain to a large body of water like the ocean, water tends to accumulate in the valleys or basins and then slowly dry up, creating dry lake beds. So in Southern California, The transverse ranges are located south of Santa Barbara. Transverse means to cut across, and they are an east-west trending, very steep range going the opposite direction of the Coast Ranges. They're located here because there is north-south compression, which causes the ground to uplift. This is due to the fact that there is a bend in the San Andreas Fault. The Peninsula Ranges are located down in Southern California near San Diego. They're northwest trending valleys with topography similar to the Coast Ranges. The geology is similar to the Sierra Nevadas, as it's made of granite, and these also include Catalina Islands, which are off the coast of California in the south. The Mojave Desert is a province located in southeastern California, where there are isolated mountain ranges separated by desert plains. The faults in the region tend to trend northwest, southeast, and east-west, which parallels the transverse ranges. It's bounded by the San Andreas Fault to the west and the Garlock Fault to the north. The Garlock Fault is also a strike-slip fault, but is a left lateral strike-slip fault, unlike the San Andreas, which is a right lateral strike-slip fault. The Colorado Desert geomorphic province is also located in far south California. It's a low-lying, barren desert about 245 feet below sea level, dominated by the Salton Sea, and it is a downdropped area between the San Andreas Fault and the Mojave Desert. So these 11 recognized geomorphic provinces exist because of past and present geologic processes in California. These processes include a convergent boundary, or a subduction zone, and all its trimmings, like accreted terrains, that originally formed the volcanic arc where the Sierra Nevada is now, and a present-day convergent boundary which forms the active volcanic arc of the Cascade Range. The transform boundary, which is currently dominated by the San Andreas Fault and strike-slip faulting, is part of the accommodation of stress of all the faults and plate motions. The Garlock Fault has formed a left lateral strike-slip fault. There's tension caused by normal faulting, which causes the basin and range, and then volcanic processes past and present that are either due to plate boundaries or they're in places where there is no plate boundary, like the Modoc Plateau. Lastly, erosion, including water and glacial erosion, as well as deposition, accounts for the sediments filling up the Central Valley, are the last two geologic processes that are the primary reasons why these geomorphic provinces are different. So as you can see, California has a very complex geologic history. So rock formations that are now adjacent often have very different histories. It has a history of multiple tectonic collisions. Some of the larger collisions associated with major episodes of volcanic activity, faulting and folding, and mountain building. So I've included some videos on the main concepts page which go over some of these processes in detail. The most recent period of mountain building is actually still going on, and nearly all of the current landforms you see in California right now are actually pretty young in terms of geologic time, at a few million years old. And the San Andreas Fault itself is actually about 30 million years old. So California also has some of the oldest rocks in North America. Not as old as the Grand Canyon rocks, but some of them in California are more than 1 billion years old. They're located in eastern deserts such as the Death Valley area and the eastern transverse ranges. Most of the rocks in California are much, much, much younger than that. The way these rocks are distributed suggests that the west coast of North America was in the past located well to the east of all but the southern end of what is now California. I'm just going to go briefly over the sequence of tectonic events in California that form the landscapes in the geology we see today. So about 80 million years ago, there was subduction of an oceanic plate beneath North America, and a volcanic arc formed, which became the roots of the Sierra Nevada. So most of the rocks in the Sierra Nevada are granite or granitic, and they are the remnants of magma chambers of the volcanic arc that stopped being active and then allowed those magma chambers to cool slowly to form plutonic or intrusive igneous rocks. So then 40 million years ago, the oceanic plate that was being subducted beneath the North American plate, which was called the Farallon Plate, was finally fully subducted beneath what is now California. And then between 20 and 30 million years ago, a new boundary formed in the area that is between the Pacific and North American plate. This is a transform boundary characterized by the San Andreas Fault.